Hello, this is page 5 of your SBAC review for 8th grade at Mercer Middle School, Ms. Agapov, Allen, BR, and Dixon. This standard is a continuation of the previous page's standard about irrational numbers. Circle all expressions that have a value greater than 5. So notice that we don't have to find anything exact here, we just need to know if it's bigger than 5. So 4, take away the square root of 9. Well, I already can tell that's not going to be greater than 5, because if we're taking away the square root of 9, we're going to be taking away some amount that's not negative. So that's going to be less than 5. But we can do some work to really prove it to ourselves. Square root of 9 is 3. 4 minus 3 is 1. So that's definitely not greater than 5. We're not going to circle that one. B, 2 times pi. 2 times approximately 3.14. I could even say a little bit less than that. 2 times 3 is 6. So that's about 6. It's a little bit more than 6. That's definitely greater than 5. I don't even need to say 6.28. I don't even need to do that because it's an estimation bigger than 5. 5.7 or 5 7/10, take away 6 root 20. That takes a little more work to think about. So the square root of 20, let's start with that. Square root of 20 is going to be, let's see, 4 times 4 is 16 and 5 times 5 is 25. So it's going to be approximately 4 point something. So 4 squared is 16, 5 squared is 25. It's kind of in the middle, about 4.5-ish. 6 divided by 4.5. That's going to be an improper fraction. It's going to be a little bit more than 1. So I don't even need to finish. 5.7 take away more than 1? Well, 5.7 take away 1 is going to be 4.7. And I'm taking away more than 1, so it's going to be less than 4.7. Is that greater than 5? No, it's not. So again, just estimating. Moving on to Pythagorean theorem. We've got a proof of the Pythagorean theorem and its converse for this standard. Right now we're not explaining the proof, but we're just more working on the Pythagorean theorem here to figure out which one of the following triangles is not a right triangle. Be really careful when you see the word not to include that in your thinking the whole time. I think often students make a mistake and they say, oh, this is a right triangle, they circle it, but then they get the question wrong. It's frustrating. So we need to know, is this a right triangle? In order to figure that out, we don't have a right angle here, we wasn't given, but I do know that if a squared plus b squared equals c squared, this must be a right triangle. Now, this is the longest side, so it must be c. It doesn't matter which one is a, which one's b. So we'll just say 6 and 8. Is this true? 6 squared plus 8 squared equals 10 squared. If that is true, this must be a right triangle. If it's not true, this is not a right triangle. It's another kind of triangle. 6 squared is 36. 8 squared is 64. 10 squared is 100. 30 and 60 make 90. 6 and 4 make 10. 90 and 10 make 100. So that is 100. That is true. So yes, this is a right triangle. So I'm not going to circle it because it says which of the following is not a right triangle. So I'm not going to circle A. This says same thing. A, B, and C. It's just this time the square root of 3 is the side length. It's a little more complicated, but we can still do it. Longest side is C. The other two sides are A and B. Is this true? The square root of 3 squared plus the square root of 8 squared is the square root of 11 squared. I don't know. We'll check to see if it's true. Square root of 3 squared, those are like opposites, inverse operations. So the square root of something, and then square it again, you're going to end up with just 3. For example, sometimes a different number will work for this, for making sense of this. The square root of 25 squared. Well, we know what the square root of 25 is. It's 5. What's 5 squared? It's 25. So the square root of 25 squared is just 25. Hope that helped, that little side note. Then we've got the square root of 8 squared, 8. Square root of 11 squared, 11. And look, 11 equals 11. That is a right triangle. So should we circle either one of these? No, they're both right triangles. So we're not going to circle any of them. A little bit tricky on that one. Question 4c, what is the distance between points -10, -4, and 9, -12? So because these are 2 points, that means every point has an x value and a y value, because on a graph, you'd have a point x, y, for example, and another x, y, for example. And to find the distance between those 2 points, you'd need to know how you would move diagonally in this case, but then you'd also need to know horizontally and vertically how you would have to, what distance you'd have to move, so that you can then use the Pythagorean theorem to find the distance. So we have an x value here, we'll call this x1, and this one has an x value, we'll call x2, meaning the first and the second x value. Each point also has a y value, so we'll call that the first y value, y1. This will be the second y value, y2. So when we're finding the distance between those points, we can find the change in x, which is right here, the change in x, and we can also find the change in y between the y value of this point and the y value of this point. So we'll find change in y. Well, in order to do that, let's literally find how far apart y1 and y2 are, the change between those 2 points. Now the example I did over here does not match what I actually have for these 2 points, it was just an example of what it might look like. So 9, negative 12, actually some of you do find it helpful if you do a little sketch really quick. So positive 9, negative 12, I'm not being exact by the way, 9, negative 12, and then negative 10, negative 4. Negative 10, negative 4. This is very much an estimate of the location of the 2 points that I'm trying to find the distance between. So now if I have a diagonal line here, I can find the change in y and I can find the change in x. That would be my A and my B of my right triangle, and that would help me find my C, which is what I'm looking for, my distance between the points. So let's do that. y2 minus y1 would find me the change in my y values. Or that would be the vertical distance between the 2 points. That would be this right here. So negative 4 is where I start, and I'm finding the change, so the distance between that and negative 12. Notice also I put y2 minus y1, and I just made the mistake of doing y1 minus y2. It doesn't matter what order you find the distance between, as long as you keep it consistent or the same the whole time. Now let's find the change in x. So I started with y1, so we got to start with x1, negative 10, take away 9. So how far apart are these points? I could just figure it out by doing this math problem, but we're also going to think about it in just a second. Negative 4 minus negative 12, minus negative becomes plus. Negative 4 plus 12 is 8. Let's check that. Negative 4, I'm already below 0. I'm going to go down to negative 12. So negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12. I moved down 8 spaces. So 8 is the side length of that right triangle. Now let's find the change in x, or that horizontal distance right here. So negative 10, take away 9, is negative 19. So let's figure that out. We've got negative 10 is way over here on the left of 0, and positive 9 is way over here on the right of 0. So not only do I have to travel 10 spaces to get to 0, I'd have to travel 9 more to get to 9. So this distance is 19. That is my side A. Now this is how to find slope. So don't get confused about why I'm using this method here. Technically I found the slope of the line, but I actually want to find the distance. So I'm going to use this information to find my distance. So I've got one side length, this is A, and I've got my other side length, this is B. So I've got A squared plus B squared equals C squared. I didn't even need the negative because I just want to know distance, and distance is always positive. It's how far apart 2 points are. I don't care which direction. Now I'm going to find what C is. 8 squared is 64. 19 squared is, I'm assuming you don't know what 19 squared is. It's, well, 20 squared is 400, so it's slightly less than 400, but you can go ahead and use a calculator for that. 19 squared is 361 equals C squared. Now I'm going to find the sum of 64 and 361, which is 425. Now here's where sometimes students get confused. The last step here is, if C squared is 425, then C would be the square root of 425. So the square root of 425 is 20.62. I used my calculator for that. So that distance between those 2 points is 20.62 units. That's how far apart those 2 points are. So Pythagorean theorem, when there's a right triangle. It didn't seem like there was a right triangle, but there really was. We didn't have to draw this picture, by the way. If the picture helps you, great. If you can just use the slope formula to figure out the change in y and the change in x and use that, that's fine too. Either way. All right, last question on this page. Apply the Pythagorean theorem to determine unknown side lengths in real-world problems. So in this case, we have two airplanes. We have the calculating which plane is closer to the base of the Orlando Tower. So here's the base right here. And I need to find out how long that distance is. And I'll also need to find out how long this distance is. So I've created two right triangles by looking at those diagonal distances. So I need to find my first triangle. So I've got altitude is 20,000 feet, 20,000 squared, plus this distance here is marked as, let's see, that's 16,400. And I'm trying to find this distance, which is c. And then we'll just do the equation for the other, but we'll solve them separately. So this distance, our altitude, or our side A, is 8,000. This is a little bit trickier. This distance here is 16,400, but then this distance is 6,560. So I actually have to add those two together to figure out how long that side of the triangle is. So I'm going to show my work right here, being really careful to line up my place value. I also could just add it together in my calculator. You can use a calculator on this standard. So we've got 16,400 plus 6,560. Be really careful not to miss any zeros. And you should get 22,960. So that's how long this side is. So 22,960 squared equals c squared. So at this point, I can't tell which one is longer. So I'm going to do some math to figure it out. 20,000 squared. Now we're going to end up with some really, really big numbers here. So I'm actually going to do all of this. I could write it all out, but I'll show you what happens when I do that. 20,000 squared is 400 million. So, you know, I could write it, or I could just add it to my other value in my calculator, but sometimes mistakes happen in that case. So I'm just going to take the time to do that. It's really easy to miss a decimal or a zero, or miss something else with large numbers or decimal numbers. 16,400 times 16,400 is 268,960,000. And then I'm going to write plus, and I'll do 400, 1, 2, 3 zeros, 1, 2, 3 zeros, 400 million. I get 668,960,000 equals c squared. I'm not going to touch my calculator except for then to take that number and find the square root of it so I don't make any mistakes. So 25,864.26, or 26 hundredths. So I don't know yet. Maybe this one's longer. We can figure it out by doing our calculations. So 8,000 squared is 64 million. $22,960 squared in my calculator is 527,161,600. And then I'll press plus so that I hold that number in my calculator. 64 million. And I get 591,161,600. And finally, take the square root. And I get 24,313.82 equals c. So it asks me, remember, always reread the question. It asked me, calculate which plane is closer. Closer means less distance, and 24,000 is less than 25,000, so plane B is closer. Now again, that might not have been obvious to you. It looks like plane B is farther away, but this might be far off in the distance. So always trust the numbers you see rather than trusting the picture. So we use the picture to get us our numbers, but we calculate it. Alright, remember there are other videos you can watch too if you need any help on the other standards. You can also just use the other videos to check your work after you're done with your packet and ask any questions of your teacher.